In this video I'm going to show you how to blend some colors together, and this is a great coloring technique for any fractal you have that doesn't fill its polygons. So like something like the ice fractal or the tree fractal or something that's really just lines and not polygons. It's kind of hard to make or the dragon curve, it's hard to make those pretty because there's nothing to fill in. But you could do some crazy mathematical coloring to blend some colors together and make it cool. Now, the first thing you're going to understand when you are trying to blend these things is that we're going to um, do a weighted average. That's the whole mission here, is that you're going to do a weighted average. So if you have two things that you're trying to blend together, we're going to call them thing 1 and thing 2. Basically, a weighted average means that these two ratios you're going to use add up to be 1. So this would be like, and this is really what you do in the midpoint formula when you're doing midpoint in geometry, except for midpoint formula you want half of one thing, half of another. You want half of this coordinate's x and half of that coordinate's x, half of this coordinate's y, half of that coordinate's y, but it doesn't have to be half. So you could say I want like 75% of this thing and 25% of that thing, and so that would give you some kind of blending that would be beautiful, but it doesn't have to be necessarily those two things. You could say I want you could say I want 40% of this one, which means you would have 60% of that one. You add that together, you get a weighted ratio. Now, or a weighted average. Now the thing is, mathematically what you're doing is you're going to say that you want some ratio here, which is a decimal. Make sure that cannot be, you don't want that to be bigger than 1. That'll mess things up. And then over here, that means you want 1 minus that ratio. I'm writing with my mouse again, so don't judge my handwriting. You want 1 minus that ratio as your multiplier over here. When you add that together, you're going to get a beautiful blended weighted average. Now, the things that we're going to be blending are not coordinates x values. They're going to be like a colors. You've got one color's red value. By the way, you can say get red like that. So sorry, I ran out of space there, but you could talk to a color and ask for his red value, and then you could talk to another color and ask for his red value. Now you're going to have to do this with all three components, the red value, so that would give you some kind of blended red value. You're going to do that with the green value, that would give you blended green, etc., etc. Now, once you have done all three of those things, then you could make yourself a new color. Look at that handwriting with the mouse. That's created out of those blended red, blended green, and blended blue that you calculated, and that would be gorgeous and look, halfway between those two things or a quarter of the way between those two colors, and it would be awesome. Now, the thing that you have to do is you have to have a ratio of something to blend with. So you're going to pick two colors up front. You got that. Now you need some ratio. What I would do is I would do a ratio of distances. So let's say here's your screen. I'm going to show you an example where I weighted things based on the ratio of their distance from the middle of the screen. Now, for you to have a ratio, you have to have a denominator, and so the denominator would be kind of like the maximum distance that somebody could be away from something. So what I did first is I said, you could say some, and it doesn't have to be to the edge of the screen, it could be to the edge of your fractal or whatever, but here's just a quick example. Everybody has some kind of, the maximum distance you could be from the center is this, right? Which is, if you have a square, side length on the square root of 2 over 2. Math. Then you have some point which is like you, right? So like here's me. Some point that you want to deal with, right? That point has some distance from the center of the screen. That's your distance. Now, so that would mean that the ratio that you want to be talking about is basically my distance from the center over the maximum distance from the center. So there's your ratio. Now you have a ratio that you can multiply by one person's red and the 1 minus that times the other person's red, etc. And so that's pretty much all you're going to do is you would look at, now you probably have to write a distance function, but you look at this coordinate that you want to color, you figure out how far it is from whatever thing it is that you want. You have some maximum distance that gives you a ratio. Once you have that ratio, you can do that weighted average between the two colors reds, the two colors greens, the two colors blues, and then you have it. Now, it actually turns out to look really cool. So I did, in this example, I did everything based on the center. Now I've randomly picked two colors. So this coordinate right here, when I went to color him, I went and calculated a color for him. Now his distance from the center is 0. So in the weighted average, one of the colors died because you multiplied it by 0. The other color got all of the weight. And so the pink got all the weight. Out here, his distance is the maximum it could possibly be. So when you said that you wanted so this guy right here, this is the same thing as that, and so you get a weight of 1, and so that color green got multiplied, all of his components got multiplied by 1, but the pink got multiplied by 0, and that one colored perfectly green. And then as you go in between, it's something like that. So every time you're going to draw a line, you would take one of those coordinates, run it through your algorithm to calculate a blended color for it based on its distance from whatever. It doesn't have to be the center. And once you have that, it would be beautiful. Now, one pro tip that you want to do is you want to make sure that this thing, that has to be less than or equal to 1. If it gives you something bigger than 1, then when you multiply, you'll get something, a color component greater than 255, and it will explode. So you could just make sure, you could actually use math.max if you want to. You could do a little, no, sorry, it wouldn't be max, it would be min of your ratio and 1. So in that case, in that case, that would most of the time just give you the ratio unless the ratio was too big. So if you did, this is like training wheels. If you did mess up your math, at least this would not break the color that you tried to make. But anyway, so have fun with that. It makes a really cool effect, and it is beautiful. Now let me show you, I'll show you real quick how I tested this. How I tested this to make sure I liked the colors is, first of all, I made 2 stupid random colors. Once I made those random colors, then I went through and I said go all over the screen, make a coordinate, and then I called this function I said what color should that coordinate be, and I drew it, and that's what's in, that helped me to test that awesome color blend. So that'll make a really cool dragon curve or a really cool ice fractal. Have fun with that.